Presenting the LEA 3000. Electricity. It changed the world. But what if its supply became unsustainable or unobtainable for most of the ordinary citizens? The choices we make today could be the difference between electricity accessible for all or back to the ages of candlelight, when you and I can no longer afford to pay for it. In this video, we are attempting to get your attention by presenting to you a real, sustainable, affordable solution. The LEA device. We have taken the unusual step to showcase this video in a bid to make the public aware of the existence of the technology. A 500% increase in electricity charges is on its way to be implemented over the next 4 years. This technology will reduce your power bills by at least 50%. The price increases of electricity currently imposed upon us do not make any economical sense. It is simply designed to allow the uranium fuel price to become a so-called cost-effective and safe source of energy able to compete with coal and gas. For those who are wanting to save the environment, it is a great opportunity. And for the ones who are wanting to save money on their electricity bill and save the environment, it must be their ultimate goal. This technology must be lobbied for, and in order to have it implemented into the grid collectively, we must demand it by contacting your local, state and federal members of parliament to take action instead of vocal promises, not only on the environmental issues, but to protect our way of life. Further, on the question of evaluation. Our technology has been independently tested by SGS, which is a Swiss-based company specialized in the field of certification and verification by providing a 55-page full engineering service report. Previously and additional. Numerous independent evaluations have been conducted by PhDs and electrical engineers to validate our technology to satisfy investors. All of the tested equipment used in this video has been tested and calibrated to NATA traceable certification. Notice the LEA device 3000. The LEA is not a perpetual motion device. The LEA, or the Ludwig Electricity Amplifier, or LEA, its input electricity amplification capability means that the amount of the measured input power in watts received by each system is less than the output watts as generated and supplied to a load by each system. In dollar value, if for example your electricity bill was, let's assume, $100 per month, this amount will be reduced to $50 or less. This is tremendous news, as in fact does promote the economy at all levels and definitely would extinguish any occurring blackouts or brownouts across the whole country. The SGS report is available to interested parties. For the ones who want to express their interest, you can contact us at admin@lutech.com.au for the Oceanian region, or for the international at admin@evergreenltd.com, Hong Kong. Further note that the devices in these videos are prototypes only and are not for sale. Further, in the next clip showing a LEA device running, basically the LEA device is producing an AC output, which in this case has been rectified to DC and filtered by capacitors. It is further connected to a light board containing a DC analog ammeter and a DC analog voltmeter. The voltmeter showing us 75 volts DC. And the amp meter showing us 24 amps DC. Therefore, the output is equal to 1800 watts of DC power output. The LIA input is connected to a DC input. Further, the motor consists out of 6 motor sections, each of those motor sections having an instantaneous analog wattmeter connected to read their inputs. Therefore, the total input, or the input power, is the summation of those 6 wattmeters. The first wattmeter reading reads about 60 watts. Second meter 40 watts. Third meter 60 watts. Fourth meter 60 watts. Fifth meter 60 watts. And the last meter 65 watts, for a total of 325 watts DC input power. Efficiency being output over input is then equal to 553% efficiency. The following clip is in regards of the operating temperature of the LIA coils, which has been measured by an infrared temperature gauge set on Celsius degrees. The first or top tier showing 32.6, the middle one 31.6 and the bottom one 30.6 grade Celsius, which is the closest to the concrete. The temperature on the wall is 43 degrees Celsius plus. All devices are running cool or at ambient temperature. Indeed, we're running very cool. A 5 kilowatt LIA unit. The following video clip is a preview of a fully designed 5 kilowatt LIA device and ready to proceed into making molds to produce the plastic components to assemble LIA devices. 7 molds are needed to be built for a complete clip-on system. The total cost of making the 7 molds is about 1 million Australian dollars. The maximum number of plastic components produced by each mold is approximate 1.2 million pieces and is known as a long run. The number of 5 kilowatt units which can be assembled from a long run is approximately 125,000 LIA units. The same components can be used to build 10 kilowatt units. Consequently, the number of the units is then approximately half, or 62,500 LIA units. The following clip shows a half-tier section as produced by a mold. A tier consists of 2 half-tiers clipped together to hold coil cores arrangement. A special design clip secures the coil core arrangement into the tier as shown. The rotor also consists out of 2 half sections as produced by the mold, and when clipped together will hold the permanent magnet secure. In the last clip you see a fully assembled 5 kilowatt LIA unit. Further, my name is Louis Brits, a director of Lutec Australia and inventor. On behalf of myself and Lutec Australia, I'd like to thank you for your interest.